Hello. I can factor cubes, meaning sum of two cubes and difference of two cubes, using ABA2, ABB2, and SOAP. Basically, there are two formulas for sum and difference of two cubes, one for sum, one for difference. They're very similar, and we want to just have those memorized. So we have A cubed minus B cubed equals, we have A cubed plus B cubed equals. They're both AB, A2, AB, B2. And of course, I have a song for this. AB, A2, AB, B2. Now, my signs. There's an acronym, and that acronym is SOAP. Same, opposite, always positive. So if it's A cubed minus B cubed, it's the same. So this is minus, this is minus. The opposite of that, always positive. If it's plus, same as that, opposite, always positive. So those are your two formulas for sum and difference of two cubes. You basically need to memorize the formulas. They're both two sets of parentheses, one small, one large, ABA2, ABB2. And for the signs, we use the acronym SOAP for same, opposite, always positive. So whenever I'm factoring something, is there a GCF? No. There are two terms. Two terms is either dots or cubes. Is it dots? Is it a difference of two squares? Well, no. X to the third and 8 are not perfect squares. Is it sum or difference of two cubes? Yes. X to the third is a perfect cube. All multiples of 3 are perfect cubes. And yes, 8 is a perfect cube. I'm not going to go into a full lesson with perfect cubes, but 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And why not keep on going? 6 times 6 times 6, 7 times 7 times 7, 8 times 8 times 8, 9 times 9 times 9, 10 times 10 times 10. Use a calculator if you need to. 216, 343, 512, 729, grand, 1,000. With exponents, x to the first times x to the first times x to the first is x to the third. I guess I'm going to do a full lesson on this. X squared times x squared times x squared. When I'm adding, I add the exponents. X to the sixth, x to the third times x to the third times x to the third is x to the ninth. So all multiples of 3 for exponents are perfect cubes. So write PC for short. And to find the cubed root of x to the ninth is x to the third, x to the sixth is x to the second, x to the third is x to the first. We divide the power by 3 for cubed root. So going back to this, yes, they're both perfect cubes. So this is minus, so I write a cubed minus b cubed equals small parentheses, big parentheses, AB, A2, AB, B2. So, same, opposite, always positive. So what are A and B? A is the cubed root of the first term, and B is the cubed root of the second term. The cubed root of x cubed is x. The cubed root of 8 is 2. So x cubed minus 8 equals a minus b is x minus 2. A squared is x squared. AB, x times 2 is 2x. D squared, 2 squared is 4. That's it. You might be saying, well, can I factor further? I see a trinomial. You will never be able to factor that trinomial that you get because there's no numbers that multiply to 4 and add 2. So you're done. Let's do another one that's relatively basic. And then we'll do one that's not so basic, and then that's it. Is there a GCF? No. Two terms, dots are cubes. These are perfect cubes. It's minus, so I'm going to do, did I do a minus last time? I did a minus last time. Let me find a plus. Let's do number 4 instead. So, not perfect squares, they are perfect cubes. Since it's plus, I'm doing a cubed plus b cubed, small parenthesis, large parenthesis, ab, a2, ab, b2, SOAP cubes, same, opposite, always positive. Take the cubed root of each. The cubed root of z cubed is z. The cubed root of 64 is 4. Z cubed plus 64 equals z plus 4. Z squared minus 4z plus 4 squared is 16. That's it. Let's do one that's a little bit trickier. Let's do number 7. Is there a GCF? No. Two terms. Perfect squares. Well, the first one is actually no. The first one is not a perfect square. They're both perfect cubes. So, a cubed minus b cubed equals small parenthesis, large parenthesis, ab, a2, ab, b2. SOAP cubes. Same, opposite, always positive. Same, opposite, always positive. A and b are the cubed root of each. The cubed root of 1,000 x to the 12th. Well, the cubed root of 1,000 is 10. For the exponent, we divide the power by 3, so 10x to the 4th. Cubed root of 27 is 3. Cubed root of y cubed is y. So 1,000 x to the 12th minus 27y cubed equals a minus b is simple, 10x to the 4th minus 3y. Now for a squared, I'm going to write it in parentheses as 10x to the 4th squared plus ab. I'm going to write it as 10x to the 4th times 3y. And then b squared in parentheses 3y squared. And now I'm going to kind of do that multiplication in a separate step. So 10x to the 4th squared, everything inside gets it. That's 100 x to the 8th. You could also think of it as 10x to the 4th times 10x to the 4th to come up with that value. 10x to the 4th plus 3y is 30x to the 4th y. 3y squared is 3y times 3y. Or you can think of it as everything inside gets it. Either way, it's plus 9y squared. So if your a and b have like multiple variables or coefficients, when you're subbing into a squared plus ab plus b squared, I would just do them in a separate step. And that's it. Practice. Know your formula. If you don't know your formula, you can't do this. And then just practice. See ya.